Welcome back with another video on TryHackMe.com. This is Zaheen Azir and we are doing container hardening, which is under container security, and container security is under DevSecOps path. So let's get into it. Learn how to implement the mechanism designed to secure your Docker container. It is easy and it will take 40 minutes. So let's see. Most of it is it's theory, I think, and the last task is practical. So let's see if we are able to cover this one in 2 videos. Okay. Let's continue with the introduction here. Task 1. So far, this module has started with the basics of the Docker and potential vulnerabilities associated with the containers. This room will teach you the various ways of securing your containers. Learning objectives: secure the Docker daemon to prevent unauthorized interaction. Sure. Correctly assign privileges, capabilities to containers, prevent faulty or malicious containers from exhausting a system. Utilize security features such as Seccomp and AppArmor to define how your container will behave with the operating system. Okay. Practice good hygiene by reviewing Docker images for vulnerabilities. Implement frameworks and tooling that review your code for vulnerabilities. Awesome. Prerequisite: in order for you to complete this room, it is essential that you are familiar with the various components of the Docker. I highly recommend completing the intro to Docker, which we have already done. So just check the video on the playlist on my YouTube channel. You will get to know the intro to Docker videos where we cover everything. Room before proceeding, answer the question below. Read the above before proceeding to the next task. Okay, I will just click on complete and we are good to go. Task 2. Alright, task 2, protecting the Docker daemon. You may recall the container vulnerabilities room that a Docker daemon is responsible for processing requests such as managing containers and pulling on uploading images to Docker images, Docker registry. Docker can be managed remotely and is often done in CI, continuous integration, and CD, continuous delivery, or deployment or development. I mean, all of these words can fit here depending on the context. Pipelines, for example, pushing and running new code in a container or another host to check for errors. Okay, if an attacker can interact with the Docker daemon, they can interact with the containers and images. For example, they launch their own malicious containers or gain access to the containers running applications with sensitive information such as databases. All right. The Docker daemon is not exposed to the network by default. All right. Must be manually configured. However, exposing the Docker daemon is a common practice, especially in a cloud environment such as CI/CD pipelines. All right. Implementing secure communication and authentication methods such as those listed below are extremely important in preventing unauthorized access to the Docker daemon. So we saw that one in our previous room, that we were able to connect to the Docker daemon without any authentication from a remote computer, and we were able to exploit that in a previous room, right? So this is where we need to configure the authentication and the other communication channel to be secure. So let's see how we're gonna do that. SSH. Developers can interact with other devices running Docker using SSH authentication. To do so, Docker uses contexts which can be thought of as profiles. These profiles allows developers to save and swap between configuration for other devices. For example, a developer may have one context for a device with Docker for development and another context for a device with Docker for production. Oh, I mean, this is very dangerous. I mean, if you have access to production, this is very dangerous on the developer machine, right? This should be done through an automated tool or somebody who should have the access, okay? Somebody trusted. Note, you must have SSH access to remote device. Your user account on the remote device must have permissions to execute Docker commands. As the developer, you will need to create the Docker context on your device. Please see the code snippet below to create a context within the Docker. All right. So creating a new Docker context. Docker context create Docker host SSH and then the my user at remote host description is equal to development environment dash host. So this is all we need to mention here. Successfully created context development environment host. All right. Once this has been completed, you can switch to this context where all Docker related commands will now be executed on the remote host. Okay. So for example, I can run the commands directly to the remote host by using the context here. So in the context, we know that the Docker, we mentioned the username and host name. I think once you create it, it will also ask for the password and you will be connected there, right? Docker context use development environment host. Current context is now development environment host. Okay, where we are mentioning the password or something like that. So exit this context and, for example, use your own Docker engine. You can revert to default via Docker context use default. Okay. Now I get it. This is not entirely secure. Yes, there is no password. For example, a weak SSH password can lead to an attacker being able to authenticate. Strong password hygiene is strongly recommended. Some tips for a strong password have been included below. High amount of characters, special characters such as exclamation, at, pound, and dollar. Capital letters and numbers placed sporadically throughout, like this, as you can see. Super secret password. Docker contexts allow you to interact with the Docker daemon directly over SSH, which is a secure and encrypted way of communication. TLS encryption. All right. So we can do the Docker context, which will allow us to interact with the Docker daemon with SSH, which is a secure way of doing it, especially with the password. Okay, now TLS. TLS is for the communication, network communication, right? TLS encryption, the Docker daemon can be interacted with using HTTPS. This is useful if, for example, a web service or application is going to interact with Docker or a remote device. To do this securely, we can take advantage of cryptographic protocol TLS to encrypt the data sent between the devices. When configured in TLS mode, Docker will only accept remote commands from the devices that have been signed against the device you wish to execute Docker commands remotely. All right. Creating and managing TLS certificate is out of scope for this room, as you will often need to consider factors such as expiry date, strength of the encryption for your environment. Once you have created your certificates, you can tell Docker to run in TLS mode with the generated certificate. So either these could be self-signed certificate by a local authority, or you can purchase this certificate from global authority, just such as Verisign. Okay, so it really depends if you want to save the money, or if you want to go with the self-signed certificate. These are as secure as the other ones, but trusted chain will not be there for the self-signed certificate outside of your organization. Okay, which is usually what we need. Server at THM and Docker D, then TLS verify, and then the TLS CA certificate myca.pem, then TLS certificate myserver-cert.pem. So CA is certificate authority. Then TLS key myserverkey.pem, and then the IP address here you are mentioning on port is 2376. We know that on HTTP it was 2375, and now if you want to use the TLS version, the port will be 2376. Okay, and this was on the server side, and now on the client side we do the Docker TLS verify, TLS cert, and we'll mention this myca, TLS cert, client-cert.pem, TLS key, client-key.pem, and then the server IP addresses and this one. All right. So we are mentioning 000. That means all the IP addresses that are there on the server. You can also limit this one, but it is okay to go with 0000 here. Yeah. It is important to remember that this is not guaranteed to be secure. For example, anyone with the valid certificate and private key can be a trusted device. That is true. I have explained the argument used in generating a TLS certificate and key in the below table. Sure. Argument description. TLS CA-cert. This argument specifies the certificate of the certificate authority. A certificate authority is a trusted entity that issues the certificates used to identify devices. Okay. TLS cert. This argument specifies the certificate that is used to identify the device. TLS key. This argument specifies the private key that is used to decrypt the communication sent to devices. All right. So we are all ready to the question answer. What would the command be if we wanted to create a Docker profile? So we'll copy paste. Docker context create. So I'll copy paste here. As you know, I'm a big fan of copy pasting. What would be the command if we wanted to switch to a Docker profile? I think it's use Docker context use. All right. Okay, awesome. So we are all ready to the task 3. We are 11 minutes into the video, so I think we'll be able to do maybe until task 6 or 7. Let's see how it goes. All right, implementing control groups. We know that we use the control group C groups vulnerability to compromise or exploit the Docker container in our previous room. So let's see how we're gonna do this, how we're gonna fix this vulnerability and what are the best practices. Implementing control groups. Control groups, also known as C groups, are a feature of Linux kernel that facilitates restricting and prioritizing the number of system resources a process can utilize. For example, a process such as an application can be restricted to only use a certain amount of RAM or processing power or given priority over other processes. This, however, improves system stability and allows administrator to track system resource use better. Of course, in the context of Docker, implementing C groups helps achieve isolation and stability because C groups can be used to determine the number of or prioritize resources a container uses. This helps prevent faulty or malicious container from exhausting a system. Of course, the best mechanism is preventing this from happening, but preventing a container from bringing down a whole system is an excellent second line of defense. Awesome. So for example, if a container is taking a lot of resources to execute some malicious script, that means it should not go beyond the limits of its resources, so that it should not compromise the whole infrastructure on which the container is running. Okay, this behavior is not enabled by default on Docker and must be enabled per container when starting the container. The switches used to specify the limit of the resources a container can use have been provided in the table below. Types of resources, argument and example. CPU. Double S CPUs in core count, Docker run IT, and then we mentioned the CPUs and then the container itself. In the memory we use the double dash memory here in KMG for kilobytes, megabytes, and gigabytes. Docker run IT means we are running it in interactive mode. Then we are specifying the memory. It will take just 20 megabytes, 20 M, and my container. Okay. You can also update this settings once the container is running. To do so, use the docker update command, the new memory value, and the container name. For example, docker update, then the memory itself, and then the container itself. Okay. We can use the docker inspect container name command to view the information about a container, including the resource limit set. If a resource limit is set to 0, this means the no resource limits have been set. Okay, so that means it can use all the resources available on the host. So docker inspect container, corrupt for brevity. Okay, so they are just showing us the related values. We can see that memory is set to 0, and CPU count is also 0. That means it can take all the available resources to run the processes on the container, which is bad. It should not be like this. Docker uses namespaces to create isolated environments. For example, namespaces are a way of performing different actions without affecting other processes. Think of these as rooms in an office. Each room serves its own individual purpose. What happens in a room in this office will not affect what's happening in another office. These namespaces provide security by isolating processes from one another. Awesome. So we know that the why we use the namespaces here. What argument would we provide when running a Docker container to enforce how many CPU cores the container can utilize? I think it is CPUs. All right. What would the command be if we want to inspect a Docker container named Apache? So I think it is Docker inspect and Apache. Awesome. We are done. Task 3. Let's move on to task 4. We are 15 minutes into the video. That means we can do, I think, 2 or 3 more tasks here in this video. Preventing our privileged container. Yeah, our privileged container. We know that in our previous room, we were able to use the privileged mode to compromise the host itself. We were able to run the commands on host operating system, and if we are able to run and get the shell on host operating system, that means you can either move laterally on the network itself, and also you can do pretty damage to the containers that are running on top of this host. Okay. So let's continue. First, we need to understand what privileged containers are. In the context, privileged containers are a container that have unchecked access to the host. As we know this before from the previous room, the entire point of containerization is to isolate a container from the host by running Docker containers in privileged mode. The normal security mechanism to isolate a container from the host or bypass, while privileged containers can have legitimate use. For example, running Docker in Docker, a container within a container, or for debugging purposes, they are extremely dangerous. When running a Docker container in privileged mode, Docker will assign all possible capabilities to the container, meaning the container can do and access anything on the host, such as file systems. What are capabilities? I hear you ask. Capabilities are a secure feature of Linux that determines what processes can and cannot do on a granular level. Traditionally, processes can either have full root privileges or no privileges at all, which can be dangerous as we may not want to allow a process to have full root privileges, as it means it will have unrestricted access to the system. Capabilities allow us to fine-tune what privileges a process has. I have placed some standard capabilities in the table below, what privileges they translate to and where they may be used. Capability description and use case. Okay, let's see. Cap net bind service. This capability allows service to bind to port specifically those under 1024, which usually require root privileges. Okay. Allowing a web server to bind on port 80 without root access. Okay, so even though you don't have the root access, if you have this capability, you can bind a process to a port, a service to a port. Capsys admin. This capability provides a variety of administrative privileges, including being able to mount, unmount file system, changing network settings, performing system reboots, shutdowns, and more. Oh, wow. You may find this capability in a process that automates administrative tasks, for example, modifying a user or stopping a service. Okay. Cap_sys_resource. This capability allows a process to modify the maximum limit of resources available. For example, a process can use more memory or bandwidth. This capability can control the number of resources a process can consume on a granular level. This can be either increasing the amount of resources or reducing the amount of resources. All right. So let's see, where we can use all of this. To summarize, privileged containers are containers assigned full privileges. For example, full root access attackers can escape a container using this method. If you would like homework, this process has been demonstrated in the container vulnerabilities. We already have covered this one before. So check my previous video, video number 15 on the DevSecOps playlist. You will find the container vulnerabilities. Okay. It's recommended assigning capabilities to containers individually rather than running containers with the privileged flag, which will assign all capabilities. Yeah, this is a dangerous one, privileged. For example, you can assign NetBind service capability to a container running a web server on port 80 by including the cap at NetBind service when running the container. All right. Docker run it rm and then the cap drop all cap add cap drop all. We are dropping all the capabilities and then we are adding NetBind service and then we are mentioning the container name here. Okay. Finally, the command cap sh print can be used to determine what capabilities are assigned to the process. Okay. We ran this command before and there were a lot of capabilities that were there out of the box. So in that case, cap ch print we can see that currently we don't have anything here. Bounding set is this one. Shown, override, read, search, phoner, some of the ch root, sysnice, and many other privileges we have. Secure, no root, no unlocked, everything is unlocked as well. It is important to frequently review what capabilities are assigned to a container. When a container is privileged, it shares the same namespace as host. We know that. We have seen this in our previous room, container vulnerabilities. Just check it out. Meaning resources on the host can be accessed by the container, breaking the isolated environment. Of course, this could be done only in case of the privileged container only. What is the name of capability that allows service to bind to ports, specifically those under 1024? It is here. NetBind service. I'll copy it and paste it here. It is not correct. Okay. Capability name. We were missing the cap. Oh, wait. Control V. Awesome. What argument would we provide when starting a Docker container to add a capability? So if we need to add, then this is the command we'll run. I think so. Let's see. Awesome. Finally, what command with argument would we use to print the capability assigned to a process? It is very easy. It is cap ch and then print. Here you go. Awesome. So we can cover one more task here. We are 23 minutes into the video. So let's see what we have here. I think this is the important room. All right. So task 5. Seccomp and AppArmor 101. Seccomp is an important security feature of Linux that restricts the actions a program can and cannot do. To explain, picture a security guard at the entrance of an office. The security guard is responsible for making sure that only authorized people are allowed into the building and that they do what they are supposed to do. In this scenario, Seccomp is the security guard. Seccomp allows you to create and enforce a list of rules of what action system calls the application can make. For example, allowing the application to make a system call to read a file, but not allowing it to make a system call to open a new network connection, such as a reverse shell. Awesome. But if you are using sockets, I don't know how it will work. Okay, move on. These profiles are helpful because they reduce attackers' ability to execute malicious command whilst maintaining the application functionality. For example, a Seccomp profile for a web server may look like following. Default actions sec scmp underscore act underscore allow. Architecture is this one, x66, 64, 32. Syscalls, read, write, exit group, open, close, stat, fstat, lstat, pool, get, dance, mun, map, mprotect, brk, break. I think architecture. I don't know what does that mean. Set, did, address, set, robust list action. Some of the actions are allowed, which is exact ve, exact v eat, and some action as an error number. This seccomp profile allows files to be read and written to, allows a network socket to be created. Very good. That was my concern. So they already put permissions for the network, but does not allow execution. For example, exec ve, which are these one. All right. So the action itself comes at the end of the list, as you can see. And if you try to run any of these, then the action will be error out. All right. Usually it comes before, if you follow the YAML convention. All right, to create a seccomp profile, you can simply create a profile using your favorite text editor. This room will use Nano as a example. Seccomp profile.js JSON has been provided below. This profile will allow reading and writing access to files, but no network connections. Okay. This is socket. And action is this one, error. Connect, bind, error. All of these are errors, but read and write are allowed here. This is much better version, I think, to see the each actions that are allowed. Okay, let's move on. With our seccomp profile now created, we can apply it to our container at runtime by using the security option seccomp flag with the location of seccomp profile. For example, like this, docker run rmit security opt. We are mentioning that we will be creating the seccomp profile here and then the container itself. Okay, so it is coming out of the box functionality, right? In the Linux operating system. Docker already applies a default seccomp profile at runtime. However, this may not be suitable for your specific use case, especially if you wish to harden the container further while maintaining functionality. You can learn more about using seccomp with Docker here. Okay, but if this is a room or yeah, it is a documentation on the Docker website itself. So if you want to, you can just go through it. We will move forward. AppArmor. AppArmor is similar security feature in the Linux because it prevents application from performing unauthorized actions. However, it works differently from seccomp before. It is not included in the application but in the operating system. This mechanism is mandatory access control, or MAC. Okay, MAC have many forms here. System that determines the action a process can execute based on a set of rules at the operating system level. We can use AppArmor. We first need to ensure that it is installed on our system. Okay, so one more time. AppArmor is similar security feature in the Linux because it prevents application from performing unauthorized action. So this is what Seccomp do, right? However, it works differently from Seccomp because it is not included in the application but in the operating system. Okay. The Seccomp is included within the Docker, I think, but the AppArmor included within the operating system of the host or in the Docker itself. Okay. So they are saying checking if the AppArmor is installed or not. Sudo aa-status. AppArmor module is loaded. 34 profiles are loaded. With the output armor module is loaded, we can confirm that AppArmor is installed and enabled. To apply an AppArmor profile to our container, we need to do the following. Create an AppArmor profile, load the profile into the AppArmor, run our container with the new profile. First, let's create our AppArmor profile. Okay, we can use your favorite text editor for this. Note that there are tools out there that can help generate AppArmor profile based on your Docker file. However, this is out of scope for this room and can be unreliable. Okay. Provided below is an example AppArmor profile. Profile.json for an Apache web server that can read files located in the var www and etc Apache 2 mime.types and run Apache 2. Read and write to var log Apache 2, bind to a TCP socket for port 80 but not other ports or protocols such as UDP. Okay. Cannot read from directories such as bin, lib, or user. This is very specific, huh? And even robust than the Seccomp. So user has been HTTPD process, and then we have capabilities set GID and capability set UID. We are mentioning from where we can read. We can read right here. We can read here. We can read write, and network access is network TCP. System logging is dev log write permission only, not read one. Allowing CGI execution IX with the per. Deny access to everything else. This is denying the access, which is anything else which is not mentioned here. Okay. So that means we are denying it. Deny bin, lib, user, and sbin. Bin, lib, and user, and they also denied the sbin as well. All right. This is pretty robust. What do you think, guys? Now that we have created the AppArmor profile, we will need to import this into AppArmor program to be recognized. Sudo AppArmor parser, read and write, and then the profile itself. With our AppArmor profile now imported, we can apply it to our container at the runtime by using the security opt AppArmor flag with the location of the AppArmor profile. For example, like this: Docker run rmit security opt AppArmor. Before we used Seccomp, but now we are using the AppArmor here. And then the container itself. Just like Seccomp, Docker already applies default AppArmor profile at runtime. However, this may not be suitable for your specific use case, especially if you wish to harden the container further while maintaining functionality. You can learn more about using AppArmor with the Docker here. So this is out of the box security mechanism available within the engine itself, as you can see. If I go here, AppArmor security profile for Docker, so it is available within the engine itself and under the security. Let's see, we have here C groups, daemon Docker surface attack, Linux kernel capabilities, content trust signature validation, and many other things. Almost all of these things are covered in this room. This is amazing. What's the difference? Well, to put it briefly, AppArmor determines what resources an application can access, i.e. CPU, RAM, network interface, file system, etc. What actions it can take on these resources. Seccomp is within the program itself, which restricts what system calls the process can make, what parts of the CPU and operating system functions. Okay. So Let's read it again. AppArmor determines what resources an application can access. Okay. Seccomp is within the program itself, which restrict what system call the process can make. Okay, so AppArmor basically tells us which resources we can access, and Seccomp basically tell us which system call we can make on top of these resources. So both can work at the same time, right? It's important to note that it is not one or the other case. Seccomp and AppArmor can be combined to create layers of security for a container. Exactly what we understood here. Awesome. Let's get to the questions. If we wanted to enforce the container to only be able to read files located in the home TryHackMe, what type of profile would we use, Seccomp or AppArmor? We will use AppArmor because it will tell which resources we can use. I think so. Yay! If we wanted to disallow the container from a system call will go with the Seccomp, such as clock adjust, what type of profile we would use. Seccomp, of course, because it will tell us which permission or set of system call we can do. Finally, what command would you use if we wanted to list the status of AppArmor? So it is AA status. AA status is here. I think we don't need to mention sudo, just the command itself. Awesome. So we are good for now. So once we come back, we'll do the task 6, 7, and 8. Thank you for joining me on this journey, guys. It's a long journey, I know, but we are enjoying it. We are sharing our knowledge, and we are learning a lot. So this was container hardening part 1. Sorry. And once we come back, we'll start the other task as well. So thank you for joining me on this journey. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe. And also, if you have any suggestions, please put it in the comments below. And I will see you in the next video. Bye bye.